very much. Four facts and one question. Fact number one, landslide risk is increasing in urban areas, particularly in the developing world. Fact number two, recognition of this increase has been accorded to many donor agencies around the world who, quite rightly now, include disaster risk reduction in all their policy statements. Fact number three is that there is really, however, very little evidence on the ground of disaster risk reduction for landslides being affected. Fact number four is that the cost to governments of a significant disaster, which necessitates the relocation of even a modest-sized community, can run into the tens of millions of dollars. Question: could we develop a mitigation strategy that would work and that would have impact in terms of reducing landslide risk? And for us, reducing landslide risk, having impact, meant really three audiences. The first audience is that of agencies like the World Bank in terms of policy. The second audience is that of governments, in other words, would they pay? And the third audience, most importantly, is that of the communities. Would they see benefit on the ground? And as we just work through these few slides, I'd ask you to try and recall those three audiences together, because it's that conjoint, for us, it's that conjoint trilogy that means impact. Landslide risk is increasing, and often for inadvertent reasons. The slide on the right shows housing density in a vulnerable community in the Eastern Caribbean where the housing density is around 70%. The water company supplies water. I'm sure it doesn't test the quality, but it probably does. I don't know. Should do. Supplies water to all those houses. Because the housing density is so high, 70%, that is equivalent to doubling the rainfall. There is no drainage provision. So for a vulnerable community already, the supply of water already makes their conditions more vulnerable. So there's a whole key to understanding risk and to managing it, developing a mitigation strategy. There's a whole raft of different factors that one needs to take into account. Typically, in such environments, individuals understandably try to do the best for themselves. They do what they think is best. They have very little money, but what they might try to do, typically they do, is to build small retaining walls, which probably respectfully does very little, but other than take a lot of their very precious income if they're lucky enough to work. The animation shows the impact of a rainstorm on the soil, and the blue shows the infiltration of that rainwater, and you can see that what happens is from upslope, the groundwater starts rising, it starts meeting the rainfall as it moves through the soil, and effectively that retaining wall, which the individual thought would provide some sort of structural security, actually acts more like a dam and at some point unquestionably will fail. It simply isn't strong enough. So what do planners, what do agencies typically do to minimise landslide risk as they would see it? Typically, they would start overlaying indices, maps of slope angle, of loading by buildings and so forth, and soil strength. All these things they will overlay to give areas an indication of those areas that are at greatest risk of landslides, and that's a very laudable thing to do. Unfortunately, what it doesn't do, however, is then tell you what to do about it. And it's at a scale that probably is a little mismatched with the actual triggering processes, and this is a really crucial point, the triggering processes for the landslide themselves, which are much more typically in these vulnerable shanty-type environments at the sort of macro household level scale, maybe a small community of 20 households or so. So those communities engage with the water supply in the way I've said, and to understand the triggering process for landslides, to reduce the risk, you've really got to model the triggering processes at the right scale. And so the slide on the left is a sort of mapping scale, very common for planners, for donor agencies and so forth, but it doesn't intimate the real solution. So we can use numerical models that we've developed, however, to isolate the triggering mechanisms, to start removing surface water and to design drainage solutions, and that's what we do. Critical in this context, though, is that we work with local people within those communities to help identify some of the problems and to deliver the solutions. And part of the engagement with that community is critical. Remember what I said at the beginning, there are three audiences here, and what wants to happen is that the community understands the benefits and sees the delivery on the ground, because that way their behaviour will be changed. So we design surface drains, we get governments and communities to agree the plans, and we promote good practice. So we communicate to all those audiences in the ways that we think communicates the science, communicates the fact that there's sufficient science underpinning the solutions, that they can have confidence. In other words, expectations are correctly aligned. Equally significantly, we get the poorest people in those communities to undertake the work. This manifestly translates their understanding of the science into their physical ability to undertake the work themselves, and so derives other benefits within the communities. One of the issues with risk reduction is, of course, it's counterfactual. What would happen if you didn't do it? And so one is really up against both promoting the science, saying that we understand the process is better now, but also looking for hard evidence that it works. And so in the Eastern Caribbean, where we've been working, some of the communities have been very, very unstable. Landslides, of course, occurring, that's why we're there. But with these mitigation measures in place, there's a sequence of events that have gone through that really confirm as best we can the fact that the strategy works. There are other things such as cost benefit. Governments want to know, if we're going to invest in this, what is the benefit, what is the cost? CMPO at Bristol that was mentioned by the Minister at lunchtime, over lunch there, have done some analysis for us, and it's a 3-to-1 ratio. There are other benefits, including health. We're removing stagnant water because we're modelling and delivering drainage improvements, so other benefits. Delivering behavioural change, i.e. delivering impact, is quite a complicated process. And I think what I said at the beginning holds true. You have to hit three audiences. So we've shown that mitigation pays, i.e. it's a cost benefit. The government is interested in that because, of course, they want to know if they invest, it's a sensible investment. Building local capacity is critical, I think. 80% of the funds that we have been spent in the local community, i.e. they have been doing the work, they've been being paid, etc. So they themselves then are more likely to achieve behavioural change and the programme to be sustainable. The third audience, taking policy into science, is something that we have sought to do. We're working very closely with the World Bank, and we're continuing to do that, and they've taken on board this policy. Of course, science into policy is one thing, but policy into science, I would suggest, is also really critically important, that if you get those three audiences lined up, there are serious policy questions that then emerge that actually define your new science agenda, and that is the position that we're in. So I would underscore the point, really, that for us, impact has been aligning three audiences: the policymakers, that is for us, it's the World Bank; governments, for us, that is the Eastern Caribbean governments; and communities, that is for us, in all those communities we worked, aligning those three communities together on a single message at the same speed, so everybody's expectation is correctly aligned, is probably for us the greatest journey that we've had on delivering impact, certainly from what we're doing. Thank you.